So this is the third little video, and what we're going to do now is talk about photosystems. So we're going to talk about what happens in the chlorophyll molecule that allows for it to produce ATP and NADPH, the energy source that'll go to the Calvin cycle. Okay, so here what we're showing you is a chlorophyll molecule, and we're showing photon light hitting it. So what it's doing, it's actually taking an electron that's in the chlorophyll molecule and exciting it, which pops up to a new energy level. And that electron then being up there is not stable. So what's going to happen is, if nothing else happens, if you do nothing else, that electron will actually come back down and return to the chlorophyll molecule down to its ground state. But when it does that, it's going to release two things. It's going to release heat. Again, the second law of thermodynamics, but it's also going to release some photons and fluorescence, and it'll actually put out a light. Now, plants do not want to sit there and glow. That is not their purpose in life. So we need to look at a way to actually kind of change how this works, and use it to the plant's benefits. So that's what we want to talk about. And so what we're going to do is look at what's actually doing this, and that's the chlorophyll molecules. And so we want to look at this a little bit closer. Okay, so here's the photosystem, and I don't have a lot for it. I mean, it's really, you kind of want to know what this whole thing is. So I want to give you some names, okay? And this is what you need to know. So we have all these little green things, and these are antenna pigment molecules. And so what I want you to know, these are the pigments that we talked about. These will be chlorophyll A, chlorophyll B, and carotenoids. Okay, so an antenna assembly is what I call this. This would be the antenna assembly. Is going to be made up of, again, chlorophyll A, chlorophyll B, and carotenoids. And so doesn't really matter which one is which. Okay, so all of these are those. And what's going to happen, a photon's going to hit this, and it's going to excite these electrons, which are going to be kind of bounced around and moved. They're excited and they move, energy transfer. And what they're going to do is end up at this one dark green molecule, and we call that the reaction center. And what I need you to know, that is a very specialized cell, and that is always going to be a chlorophyll A molecule. Okay, so the reaction center is always a chlorophyll A molecule. Now, why is that chlorophyll A molecule more special than, let's say, this one right here? Let's say this is chlorophyll A. And it's the same reason why you buy, the three reasons why you buy what they say you look for in buying real estate, and that is location, location, location. You always want to buy the cheapest house in the most expensive area, because you can fix that one up and gain money. What you can't do, you don't want to buy the most expensive house in the bad neighborhood, because there's not much you can do to fix that. My neighbor's cat playing with my pants. All right, so anyway, location, location, location. And what you need to know is this chlorophyll A molecule is actually right up against this one right here, which is the primary electron acceptor. Okay, so what's happening is photon hits this, electrons are bouncing around, and then boom, they hit this, and then they bounce up, and they go to the primary electron acceptor. So we have an electron transfer. Boom. Okay, so the electron now is up here, and again, from before, what I want you to remember is that if we do nothing else, that's going to pop that down, release heat, and it's going to put off some light, which again, plants don't want to do. Now, the picture on the right is kind of this concept, but a little bit different. So it's showing you a protein in the membrane, and they're showing you here, this would all be antenna assembly. And then what's happening is there is the special pair of chlorophyll A molecules that would be the reaction center, and the electron pops up to what we call the primary electron acceptor. Okay, so this is happening in the interior, in the thylakoid membrane. Okay, and you can see here's the stroma on one side, and here is the thylakoid space, the hollow inside the thylakoid on the other side. Okay, so I like this picture a little bit better. I think it's a little clearer to tell what's going on. But this is one on the right is maybe a little more relevant to what it actually looks like in the thylakoid membrane. Okay, but I think this one's easier to kind of understand, which is why I'm showing you both. But I want you to know those parts, okay? And I want you to know where they're located. And again, this is going to be, these will be embedded in the thylakoid membrane. Okay, and so we'll stop with that. Now it's where it's going to get difficult. So we'll end this one and